Alright, so I think I'm recording. Let's take a look at scale packet 6, which is complex numbers. Remember that we have properties of radicals. I think that A and B can't both be negative. So if we see the square root of negative 72 and 72, the largest perfect square that divides 72 is 36. So we have 6i radical 2. $225, I think, is 15 squared. I should check that. Yeah. The largest perfect square that divides 45 is 9. The square root of 9 is 3, and 7 times 3 is 21. The square root of negative 1 is I. And then we have square root 5. I like to write it like this because if I write it like this and I have the I too close to there, people don't know if I'm taking the square root of I or not. That's why I put it out in front. When you have a power of I, divide by 4, look at the remainder. The remainder is 3. So because remember, you need to remember that I to the 0 is 1, the I to the first power is I, the I squared is negative 1, and the I cubed is negative I. Even exponents will either result in positive 1 or negative 1. Odd exponents will result in I or negative I. That was odd. That's just kind of a quick check in case you do some type of silly mistake. Again, if we divide by 4, we've got 2 as a remainder. 2 over 4 is 0.5, and I squared is negative 1. So the 155 is odd, so I know it's going to be either I or negative I. .75, that's 3, that's negative I. 204, it'll either be 1 or negative 1. It's divisible by 4. Remainder is 0. The remainder is 2. .12 minus 16 is negative 4. Negative 4 plus 1 is negative 3. Negative 5 and negative 7 is probably negative 12. Plus 2, negative 10. So I just combined like terms and hope that I didn't make a silly mistake. And the same here. 24 minus 10 is 14. 14 plus 3 is 17. The negative 3i and negative 7i is negative 10i, plus 1i is negative 9i. The distributive property, multiplication distributes over subtraction. I squared is negative 1, makes that a negative 24. Binomial times a binomial. So since I squared is negative 1, this becomes 2. If I add along this diagonal, I get negative 34. If I add along the other diagonal, I get 17i if I've not made any silly type of mistakes. I don't see any conjugates, so I'm just going to multiply the first two. Bert Kreischer is on the Bob and Tom show right now. He's pretty funny. So if I haven't made any silly mistakes, I multiply the first two binomials in the form of a table, remembering that I squared is equal to negative 1. Then I took that binomial, multiplied it by 3 minus 2i, and did that in the table, and I get a final answer of negative 16 plus 28i. So multiplication distributes over addition or subtraction. I squared is negative 1, so that's a negative 8. 18 minus 8 is 10. And then if I combine these like terms, minus 46i. I don't see any common factors. I don't see any conjugates. I don't see any way to make this multiplication a little bit easier. Huh. So don't forget the subtraction. Don't forget that you're subtracting the whole thing, so you need parentheses. So if I haven't made any silly mistakes, the 7 and 2 gives me 9. And the 17 eyes take away 11 eyes gives me 6 eyes. And that's what I'm getting for my final answer there. The complex conjugate of negative 3 minus 5i is negative 3 plus 5i. When we multiply complex conjugates, a plus bi times a minus bi is a squared plus b squared. So if I have 4 plus I times 4 minus I, then I have 4 squared plus 1 squared, and I have 17. The complex conjugate is negative 5 plus 8i. So I've got negative 5 squared plus 8 squared. $25 plus 64. 25 and 64, yeah, 89. Exponents don't distribute. So if I haven't made a silly mistake here, I'm just making two tables to multiply these binomials. You don't have to make tables, but a table is an organized way to apply the distributive property. So if I haven't made any silly mistake, that's what I get. Now here I see conjugates, so I'm going to shuffle the multiplication. I'm going to look at 7 plus 2i times 7 minus 2i, and then look at 2 minus 5i times 2 plus 5i. When I multiply these conjugates together, I get 7 squared plus 2 squared. And then when I multiply these conjugates together, I get 2 squared plus 5 squared. So I've got 49 plus 4, which I think is 53. I've got 4 plus 25, which is 29. And I don't know what 53 times 29. 1537. We are not allowed to have the imaginary unit in a denominator. So I know that this fraction is equal to a common thing that you see in algebra is to multiply by the number 1. I'm going to write 1 as I over I. Then in the denominator, I get 2i squared, which is just negative 2. And here I have 7i minus 5i squared. But I know that I squared is negative 1. So I have 5 plus 7i divided by negative 2. And for me, that's fine. But technically, if they want it in standard form, you want 5 divided by negative 2. You want 7. Or sometimes, I guess I would have probably put the negative sign in the numerator. It doesn't matter. But any one of those is acceptable. So again, we're going to multiply by 1. This time, we'll multiply by the conjugate of the denominator, and that way we won't have an imaginary unit in the denominator. So we'll have 2 squared plus 3 squared. And in the numerator, what will we have? So we'll have negative 3 plus 28i. And 4 plus 9 is 13. And to me, that's fine. But if you want to put it in a plus bi form, it'd be like that. So we'll multiply by 1. We'll multiply by the conjugate of the denominator. That'll get rid of the imaginary unit in the denominator. And is that right? Yeah. The negative 14i and positive 14i cancel each other out. All right, that will let me shrink it up, so I'll just have to come over here. 14 squared is probably 196 plus 4 is 100. Let's check. I think 14 squared is 196. Yeah. So this guy is just equal to 1. Let's multiply by 1 using the complex conjugate of the denominator. You will get a squared plus b squared. And here, let's make a table real quick. I don't know how quick I'm doing this. Uh, yeah. Let's see, 29. And again, technically in standard form, the complex number in A plus BI form, but I'm fine with you leaving it like that. Again, we'll multiply by 1 using the complex conjugate of the denominator. Alright, so what do we get? Let's distribute this and we get 21 plus 14i. 9 plus 4, 13. And again, that to me that's fine. But in A plus BI form, technically, it's like this. Let's multiply this first fraction by 1 using the complex conjugate of the denominator, and the same with the second fraction, because right now they do not have a common denominator. So I'm just going to get rid of the imaginary unit. So here I have 3 squared plus 1 squared, and they're talking about different things in the NFL right now. So I can see that I'm going to have the same denominators. That's kind of nice. That I have 9 plus 1, I have 10 as a common denominator. So I can just, I don't know why I made that so big. I can just, 14 plus 5 is 19, and negative 18i plus negative 25i. Is that minus 43i? Let's double check that, because if I have 18 plus 25, yeah. All right, I'm going to do the rest on another video.